topic is about extrinsic semiconductors. Dopants are added. It's added 1 part in 10 to the power 8 parts of atom, which is a very small quantity. The doping agents are, it may be either pentavalent impurities or trivalent impurities. Pentavalent impurities means 5 valence electrons. Example, arsenic, antimony, phosphorus, etc. So it has an extra electron, it donates an electron, and it's called donor atom. Donates or contributes 1 electron to the conduction band of pure germanium. This is N type of semiconductor. For P type of semiconductor, trivalent impurities may be added. It will contain 3 valence electrons. Example, gallium, indium, aluminium, boron, etc. So they have acceptor atoms. It accepts 1 electron from germanium atom. N-type semiconductor, pentavalent impurities are added. Example, antimony to pure germanium crystal. So we have surrounding germanium crystals and Sb here. So one excess electron is there which can easily move from its place to the conduction band. So this movement contributes for the current conduction. So the donor level line lies below the Fermi level line. Fermi level line lies exactly in the center between valence band and conduction band, and donor level line, which is also an imaginary line, lies little near the valence band. So it lies near the place where there are more charge carriers. Here more charge carriers, free electrons are there in valence band, so it lies near the valence band. The donor impurity makes the germanium N-type semiconductor. Negatively charged carriers are there. By giving away its 1 electron, free electron, it donates an electron. It becomes positively charged ion, because when this electron moves from its place, a positive ion is created here. But it can't take part in current conduction because it is firmly tied to the crystal lattice. It is immobile. Germanium plus with Sb increases the number of conduction electrons because of added free electrons here. Concentration of electrons in the conduction band increases and increases the concentration holes in valence band. The donor level is 0.01 electron volt below the conduction band for germanium and 0.054 electron volt below for silicon. In N-type, electrons are the majority carriers and holes are the minority carriers. The conduction conducts by electrons is nearly empty conduction band, and the process is called as excess conduction, since there are more charge carriers, more negative electrons here. N-type has excess electrons but still electrically neutral, because positive ions are created when the electron moves from its place. So whatever be the charge, the atom becomes electrically neutral only. P-type semiconductor is obtained when trivalent impurities are like boron are added to the pure germanium crystal. So here there is one free hole here where an electron can come and fill its place. Here the acceptor level is little higher than the Fermi level line. It's near the conduction band because more charge carriers are there near the conduction band. It causes as many positive holes in the germanium. Many holes are here and electrons there in valence band, conduction band. So P as acceptor atoms, positively charged carriers. Holes in the valence band is greater than the electrons in the conduction band. The conduction is called deficit conduction because there is a deficiency of an electron in this covalent bond. So the majority carriers here are holes and minority carriers are electrons. So germanium converted to P-type semiconductor adds many holes. So P-type material has the following charge carriers: large number of positive holes, most of them being added. And then immobile impurity, by the impurity holes with a very small number of thermally generated ones as well. A very small number of thermally generated electrons. P-type has holes as majority carriers and electrons as minority carriers. So P-type holes are created. Number of holes is equal to the number of boron atoms added. So it has both majority carriers holes, minority carriers electrons, immobile ions and mobile ions as well. So this is about the extrinsic semiconductors N and P type. Thank you.